This is Math 3 6.9 video notes. That's Math 3 Unit 6 Lesson 9. The title is Solving and Graphing Radical Equations. Please be sure to put your name, not mine, your name in the upper right hand corner with your period. We're combining lessons today. We're going to be solving like we've been doing. We're also going to be graphing and compare the two. All right, first one, solve algebraically for x. So I am first just going to rewrite the problem here so that I can show my work right underneath. All right, we know that we square both sides because that's how you undo a square root. Square roots and squares are inverse operations. They undo each other, leaving behind x minus 2. And I'm hoping we all know at this time to not individual square, we have to double distribute. X minus 2 equals 2 times 2 is 4, 2 times negative 2x is negative 2x, and then I'm going to distribute negative x times 2 is another negative 2x, and that there is a positive x squared. Okay, I'm going to combine my middle terms. They are not opposite, so they're not going to undo each other. Sorry, that becomes a minus 4x and then plus x squared. And now we've done enough where we know when we have an x squared and an x in the same equation, doesn't matter if they're the same side or not. If they're in the same equation, we get everything to one side so that we can equal it to 0. So I'm going to subtract x with its like term, add the 2 with its like term, and I'm also going to rearrange it so that the x squared comes first. So x squared is positive, it's going to come out to the front. X is in the middle, negative 4x and negative 1x is negative 5x. And 4 plus 2 is 6. And we are going to continue. We're going to factor. Now we can see it's going to be a double bubble. And we can see the two signs have to be the same. The reason they have to be the same is because it has to be positive 6. So negative and a negative makes a positive. Now kids always struggle with this one. Is it 6 or 1? 6 and 1 or 2 and 3? Because negative 6 plus 1 is negative 5. But it has to be 2 and 3 because the two signs have to be the same. And if you chose 6 and 1 to get 5, one of them would have to be negative. And in this case, they have to both be positive to multiply to a positive 6. Inside outside gives me negative 5x. X minus 2 equals 0. X minus 3 equals 0. And we check. All right, I'm going to check x minus 2 first. And remember, when I check it, I plug it into the original. As a skeleton, the square root of blank minus 2 equals 2 minus blank. I just put blanks everywhere there used to be an x. And I'm going to plug in the 2 and the 2. And I get 2 minus 2 is 0, and the square root of 0 is 0. 2 minus 2 is 0, and sure enough, 0 equals 0. So x equals 2, that should be an equal sign. X equals 2 is a solution. All right, so, and I didn't finish solving off up here, and I'm hoping you guys need to do that on your own. You get x equals 2 and x equals 3 when you solve them. Add the 2, add the 3. All right, I am now going to check x equals 3. Same way. Set up the skeleton, square root of blank minus 2 equals 2 minus blank, and this time I'm plugging in a 3. 3 minus 2 is 1. Square root of 1 is 1. 2 minus, oh, forgot to plug that 3 in. 2 minus 3 is negative 1. And 1 does not equal negative 1, so 3 does not work. X equals 2 is the only solution. All right, Now it says accurately graph the system of equations, which is from the algebraic equation from part A. So we're going to take these individually. We're going to call this first one f of x, the second one g of x, graph them separately, and look for the point of intersection. According to our work here, it should come out to be 2. All right, so when you are graphing these, you want to make sure that you're getting as many points as possible. All right, so I'll do this one in this lime green. I know to move right 2 and then up 1 over 1. What I would suggest before you connect that, especially with a pen, you can lightly sketch it in with pencil if you like, is graph the other one just so you know for sure you have the correct graph. I'm going to go ahead and do the other one in pencil, and then I'll put it in pen after. 2 minus x is the same thing as saying negative x plus 2. I'm just rearranging it so I know what it looks like. This goes up 2 and has a slope of negative 1. Down 1 over 1, down 1 over 1, down 1 over 1. It intersects right there at that green dot. So I am going to put those now in red. And sometimes you have to do a lot of dots to find where they intersect. And it also helps to have this work here because you know what you're trying to get. X equals 2 is the point of intersection, and they do right there. X equals 2. So I'm going to go ahead and graph my green graph, and it looks like that. All right, in class I'll show you a tool on how to get more points on the green graph other than just the 2. All right, next one, same thing. I am going to solve algebraically. Negative square root x plus 2 equals negative x plus 4. Now it's not necessary, but I'm going to do it. I'm going to divide both sides by the negative 1. Cross out there, square root of x plus 2 equals, and you divide them both, just like a distribution. Distribute the division into the x and the 4. Negative x divided by negative 1 is positive x. 4 divided by negative 1 is negative 4. And now I'm ready, like I did on my previous problem, to square both sides. And I'm hoping you remember to quantity square that one and double distribute. X plus 2 times x minus, nope, I'm going to rewrite that. Got a little ahead of myself. The squared and the square root undo each other, leaving behind x plus 2 equals x minus 4 times x minus 4. X plus 2 equals, and then you double distribute. X times x is x squared minus 4x. Inside is another minus 4x, and then plus 16. And I'm going to come back up here to number 1 and underline that one in red because that's the color I used to graph. Okay. I'm going to combine like terms. X plus 2 equals x squared. Those are not opposite, so it's minus 8x plus 16. And I'm going to subtract the x, subtract the 2, subtract the x, subtract the 2. It looks like they're already in the right format. Gone and gone. I am going to bring that up here. 0 on the left side, which is what we're trying to do. X squared minus 9x plus 14. X squared minus 9x plus 14. Double bubble. Looks like minus 7 minus 2, so that can multiply to positive 14 and add up to negative 9. X minus 7 equals 0, x minus 2 equals 0, x equals 7, and x equals 2. And we do have to test. For me, I'm running out of room, so I'm going to do my check work on a separate piece of paper. You may have to do the same. Okay. I am going to first check, and it doesn't matter which one you check first. I'm going to first check the 7, and I plug it right in there, opposite of square root blank plus 2 equals opposite of blank plus 4. Okay, I'm using the original, and the first time I'm going to plug in 7 and see what I get. 7 plus 2 is 9. Square root of 9 is 3, and the opposite of 3 is negative 3. Equals, opposite of 7 is negative 7 plus 4. Negative 7 plus 4 is negative 3. It works. 7 is indeed a solution. Okay, now I'm going to try the next one. X equals 2, and I'm going to do the same exact thing, only this time I'm plugging in 2 to the blanks. So same setup, opposite square root blank plus 2 equals opposite blank plus 4. If you're confused where that's coming from, it's coming from the original function, the original graph equation. All right, plugging in this time, plugging in 2 and 2. 2 plus 2 is 4. The opposite of the square root of 4 is negative 2, because root 4 is 2, opposite is negative 2. Opposite of 2 is negative 2, plus 4 is positive 2. That does not work. X equals 2 is not a solution, so x equals 7 is the only one here that works, and we're going to graph. Okay. Left 2. Down 1 over 1. And right now I'm going to lightly sketch this in pencil, and I'm going to do the other one, and then the straight line we know for sure how to graph, so we're not guessing on how much it curves, and we'll go from there. And we know our answer should be x equals 7, comma, some y value. All right, up 4. 1, 2, 3, 4. And I'm just going to go ahead and use straight to pin this time because it's a line. 1, 2, 3, 4, and then down 1 over 1. And I'm just going to keep going and going and going. Where's x equals 7 even at? 1, 2, 3, 4, 5, 6, 7. It's right there. So I'm just going to go one more time and connect. Okay, so I know they're going to intersect at 7, negative 1, 2, 3. That there is where they're going to intersect. And you can see my graph actually went through there. That was just a rough sketch, but it did go through. Again, I'll give you a tool to use in class on how to come up with more points. For now, I'll tell it to you and I'll explain it more in class. So you go down 1 over 1, down 1 over 3, 1, 2, 3, and then down 1 over 5, 1, 2, 3, 4, 5. And then we have our graph. That was down 1 over 1, down 1 over 3, down 1 over 5, and then you have your graph. And sure enough, it intersects at x equals 7. Okay, we are going to finish this in class. We'll finish those last 3 when we get back into class. So for now, you are not turning this in until we get it all done in class. That's it for now.